So this video is on National 4 Chemistry, and the topic for this video is acids and bases. Now, the first part of acids and bases is the pH scale. And the pH scale is what we use to measure whether or not something is an acid or the opposite of an acid, something we would call a base. So the pH scale. Chemicals can be described as being an acid, neutral, or a base. And this is determined by the pH scale. Now the pH scale typically goes from 0 to 14. Anything with a pH under 7 is an acid. Anything with a pH of exactly 7 we call neutral, and anything with a pH over 8 we call a base, and if a base dissolves in water we call it an alkaline. So sometimes those two words, base and alkali, get used to describe the same thing. Now these colours on this scale come from something called universal indicator, which is a dye or an indicator that you can add to a chemical, and if it changes colour, depending on the colour, you can read off the number from the pH scale. But we need to know that the colours red, orange and yellow are the ones for acids. The colour green is for neutral, and colours blue and purple are for alkalis. Okay, so summarising all of that, if the pH is under 7, it will turn universal indicator red, orange or yellow. That means it's acid. If it's got a pH of 7 and turns universal indicator green, it's neutral. And if it's got a pH more than 7 and it turns universal indicator blue or purple, it's what we would call a base or an alkali. Now the sources of bases, and alkalis are metal oxides. So metal oxides are capable of changing or affecting the pH of water. If a metal oxide can dissolve, and we'd say that means it's soluble, it will make water basic. So it'll make the pH go higher than 7. However, if a metal oxide is insoluble, meaning that it cannot dissolve, the pH of water will stay the same. So only if a metal oxide dissolves will it change the pH, and it will make the pH go greater than 7. Now you can use page 8 of your data booklet to find out which metal oxides are soluble and which metal oxides are insoluble. And I'll show you how to use that on the next slide. So here is a copy of the table at the bottom of page 8. Now we're talking about metal oxides, so the column we care about is this one here, where we've got oxide written at the top. Now to use this table, what we look at is the name of the metal, which is on the very left-hand side, and then we read across to this column with oxide at the title. And what we're looking for is what letter is inside. So I'll give you 3 examples. So the first one we're going to look at is aluminium oxide. There. Now if we look at that, it's got an I written in it. That I means it's insoluble. If it's insoluble, it will not affect the pH. The next one we've got is calcium. So calcium, we read across to the oxide column, it's got S written in there. S means it's soluble, and remember, any metal oxide that is soluble will make water basic. It'll make the pH greater than 7. And then the final one we've got is potassium oxide. Now it is VS, which means it's very soluble. Doesn't mean anything different, it'll still make water basic. So if it's got an S or a VS inside, that means it will make water basic. If it's got the letter I written, it's insoluble, so it will not affect the pH. Next topic in acids and alkalis is the environmental effect of acids. Now in the previous section we looked at metal oxides, and metal oxides made things basic if they dissolve. Well, non-metal oxides make water acidic, and there's 3 examples you need to know. carbon dioxide, sulfur dioxide, and then nitrogen oxide. So it could be nitrogen monoxide or nitrogen dioxide. Now these will turn water acid, and this can turn rainwater into what we call acid rain. So carbon dioxide, sulfur dioxide, nitrogen oxides can create acid rain. Now, where do we get carbon dioxide, sulfur dioxide, and nitrogen oxides from? Well, there are some natural sources of those gases. So for example, every time we breathe out carbon dioxide, and every animal, in fact, every living thing produces carbon dioxide. Also, volcanoes are a big source of sulfur dioxide. But these are things that the planet has naturally dealt with for centuries. What has become a big issue is that we're producing even more of these gases through burning fossil fuels. So things like coal, oil, and natural gas. As we're burning more of these, we're getting especially a lot of carbon dioxide in the atmosphere, and this is causing things like acid rain, which is causing the acidification of the oceans, and is also leading to global warming and climate change. So if we want to prevent such issues, what we need to do is work on using alternative energy sources and burning less fossil fuels. Next topic is acids and food. Now, acids are added to food all the time. Now, the main reason would be as a flavour enhancer. So for example, if you put vinegar on your chips, you're adding vinegar on there for the taste. Also, things like any sort of sour flavoured things, any fizzy flavoured things have citric acid on them, which gives it its particular taste. So the acids are giving it a particular flavour. Acids are also added to things to help them last longer. And if acids being used to help a food last longer, we call it a preservative. Now, while acids obviously have very good uses in foods, there are some negative effects. Too much acid in foods are bad for us. In particular, they can cause tooth decay and they can cause indigestion. Now, indigestion or heartburn, as it's sometimes called, is just when your stomach has too much acid in it, and you can then start to feel that acid in your throat, and it causes a painful sensation. The final topic for this video is something called neutralization. Now, what is neutralization? Well, neutralization is when an acid reacts with a base. Now, what that means is a base is any metal oxide, metal hydroxide, or metal carbonate. So if you're ever asked to identify something as being a base, you're looking for it starting with the word metal and then ending with either oxide, hydroxide, or carbonate. Now, the neutralization reaction is acid plus base. It always produces water. That's how you identify it as being neutralization. And it also produces something called a salt. Now, the reason why it's called neutralization is because water is neutral. So you're making something that is neutral, so it is neutralization. Now, you need to be able to name the salt. Now, a salt always has two parts to its name. So an example of a salt is something like sodium chloride. Now, the first part of that name, the sodium part, comes from the metal of the base. So to make sodium chloride, you either had to start with sodium oxide, sodium hydroxide, or sodium carbonate. The second part of the name comes from whatever acid was used. And on the next slide, I'll show you the three common acids that you can use and what name they give to salts. So the three common acids are hydrochloric acid, nitric acid, and sulfuric acid. If hydrochloric acid is used, the salt will be a metal chloride. If nitric acid is used, the salt will be a metal nitrate. If sulfuric acid is used, the salt will be a metal sulfate. So to finish with, I've got a few examples. So first one, sodium oxide and hydrochloric acid. Well, from the base part, we've got the metal sodium. So that's going to be the start part of our salt. It's hydrochloric acid. So that's going to form a chloride salt. Put it together, sodium chloride. Our second one, potassium hydroxide and nitric acid. Well, from our base, we've got the metal potassium. That's going to start our salt. And it's nitric acid. Nitric acid makes nitrate salts. Put it together, potassium nitrate. Our final one, copper carbonate and sulfuric acid. Well, copper carbonate, that's our base, and it's got the metal copper. So our salt is going to start with copper. Sulfuric acid makes sulfate salts. So put that together, copper sulfate. So hopefully you now have a good understanding of how to name salts. That has been the whole topic of acids and alkalis at National 4, and that should mark the end of Unit 1. So the next set of videos will be on a different unit.